Hi friends, I am Ramya. Today I would like to explain the importance of sign convention. Generally, sign convention is the convention which shows from which direction to measure the distances and understand the positions of the object and image. This sign convention which shows what it will show from which direction to measure the distances and understand the positions of the object and image. While studying the reflection of light by spherical mirrors and formation of images by spherical mirrors, a set of sign conventions are needed to learn. While studying this reflection of light by spherical mirrors and formation of images by spherical mirrors, while studying all this, a set of sign conventions are needed that is required to measure the focal length, object distance and image distance from the mirror, and also magnification of the mirror. Magnification is nothing but the increase in the image size produced by these spherical mirrors with respect to the object size. Means magnification is nothing but increase in the image size with respect to the object size, and this increase in the image size is produced by spherical mirrors, these spherical mirrors. So here concave mirror and convex mirror are nothing but spherical mirrors, because as shown in the figure, these mirrors are the part of the sphere. This is the sphere and these mirrors are the part of this sphere. If we cut some part of this mirror, if reflecting part is inward, it acts like a concave mirror. If we cut some part of the mirror from this sphere, if reflecting surface is outward, it behaves like a convex mirror. And here we have some rules for sign convention. Let us discuss one by one. All distances should be measured from the pole. First rule is all distances should be measured from the pole. Here in part 1 of mirror equation and part 2 mirror equation, we discussed about this pole, center of curvature, radius of curvature, focal point and focal length. Everything we discussed in the two parts. Here pole is nothing but the midpoint or center of this optical element. This is the optical element, and this is a concave mirror, and this is a convex mirror. Both are nothing but optical elements. First rule is all distances should be measured from the pole. From the pole only we have to measure every distances, whether it is to object length or image length, center of curvature, focal length. Everything should be measured from the pole itself, and the distances measured in the direction of incident light taken to be positive. Distances measured, this is the incident light direction. This is the incident light direction. If the distances measured in the direction of incident light taken to be positive and opposite to the direction of incident light taken to be negative. This is opposite to the incident light taken to be negative, and direction which is along with the incident light direction, it will taken to be positive. And height of the object and height of the image are positive, and height of the object, this is the object, height of the object or height of the image, or height of the image, if we place image here, if we measure those heights from the principal axis upward measurement from the principal axis, then we have to take it as positive sign, and negative will come if it will measure downward from the principal axis. If you measure downward from the principal axis, that object height or particular image height, it is taken as negative from the principal axis. And if we calculate the measurement or if we measure the height of the image or object from the principal axis upward, we have to take it as positive sign. And next, in case of a concave mirror, the center of curvature and focus lie in front of a concave mirror. In case of a concave mirror, the center of curvature and focus lie in front of a concave mirror. In front of a concave mirror. So signs of radius of curvature and focal length are taken to be negative, and the image formed in front of the mirror, the distance of the image is taken as negative, and the image will be formed in front of the mirror and the distance of the image is taken as negative. The image distance from pole to image distance, we have to denote it as V, and to object distance we have to denote by letter U. If the image formed in front of the mirror, the distance of the image is taken as negative, and when the image is formed behind the mirror, then the distance of the image is taken as positive, and when the image is formed behind the mirror, then the distance of the image is taken as positive. Let us take an example. When the concave mirror is placed, this is a concave mirror. When concave mirror is placed very close to the object, a virtual image is formed, and it is magnified. Magnified means big image when compared to the object. Means when the concave mirror is placed very close to the object, a virtual and magnified image means big image is obtained. If we increase the distance between the object and the mirror, the size of the image reduces and real images are formed in front of the concave mirror. Again I will tell. When concave mirror is placed very close to the object, a virtual and magnified means big image is obtained. If we increase the distance between mirror and the object, if we take the real object here or here somewhere else, if we increase the distance between the mirror and the object, the size of the image, this image reduces and a real images are formed in front of the mirror. In front of the mirror. I think you will understand. And in case of a convex mirror, let us take the example of a convex mirror. This is a convex mirror because the reflecting surface is outward and the inward surface is silvered. Here, if the center of curvature and focus lies behind the convex mirror, the sign of radius of curvature and focal length are taken as positive. Positive sign we have to take because this center of curvature and focus are lies behind the convex mirror. If the center of curvature and focus lies behind this is in front of the mirror, this is behind the mirror, then the sign of radius of curvature is from pole to center of curvature. This is nothing but pole. Pole to center of curvature, the distance is radius of curvature. The radius of curvature and the focal length are taken to be positive. If an object placed in front of a convex mirror, light rays originating at the object location are shown approaching and subsequently reflecting from the mirror surface. Are shown approaching, but they are subsequently reflecting from the surface. Each observer, these are the observers, each observer must sight along the line of reflected ray to view the image of the object. To view the image of the object, each observer must sight of a reflected ray, must sight this reflected ray along the line of reflection, along the line of reflection. Here image is formed. This is a virtual image. That is a virtual image. Each ray is extended backward to a point of a intersection, to the point of intersection. These are reflected rays. These are reflected rays. Each ray extended backwards to a point of intersection. This point of intersection of all extended reflected rays is the image location. This point of intersection of all the extended reflected rays is the image location of the object. This is the image of this object. This image is a virtual image. Here, center of curvature and focal point of the convex mirror are imaginary points and that cannot be reached. Center of curvature and focal point. The center of curvature and focal point of the convex mirror are imaginary points. Those are imaginary points and that cannot be reached. So the image is formed inside the mirror and cannot be projected on a screen. We already discussed it in mirror equation part 1 and part 2. Virtual image we cannot able to project on a screen. That's why this is also a virtual image. That's why it cannot be projected on a screen. The image formed looks smaller than the object from a distance. Here the image formed looks smaller than the object from a distance. If you see from certain distance, the image looks like smaller than the object and it gets larger as the object is brought closer to the mirror. If object is brought closer to the mirror, that image will appear to be larger. At some distance, the image looks like smaller than the object. If we brought closer to the object, as the object is brought closer to the mirror, then that image looks like larger. Once again I will tell. The image formed looks smaller than the object from certain distance. But it gets larger as the object is brought closer to the mirror. And here we will distinguish the mirrors. If we distinguish the mirrors, for this you have to do one thing. Just bring your face closer to the mirror. Just bring the persons who are hearing here. Just bring your face close to the mirror. For different types of mirrors, plane mirror, concave mirror and convex mirror. If your face close to the plane mirror, what you will observe? It will produce an image of same size. In our home, we will see our face as same as real. And if we close to the concave mirror, it will produce magnified image and your face will look much bigger. Then you will distinguish that. Concave mirror will show your face much bigger than real. Concave mirror. If in case of a convex mirror, if you bring your face to the convex mirror, it will produce diminished image and your face will look much smaller. Diminished means reduced image, short image, decreasing image. You will observe if we place your face in front of a convex mirror. So and we have some examples in daily life. We are seeing some examples. For concave mirror, I will tell you some examples. Shaving mirrors, makeup mirrors, and headlights are all examples of concave mirror. And concave mirrors are also used by ENT specialist, dentist, to see inner parts of our mouth. Mouth and ear, they will use this concave mirror, because if you place that the small size of mirror inside of your mouth, they will see small anything problematic issues are there in your mouth. It will appear clear to the doctors. That's why they use concave mirrors. And in case of convex mirror, in hospitals, roads, ATM centers, rear view mirrors. In vehicles we will use rear view mirrors now. Those mirrors are examples of convex mirrors. So this is the simple topic. Thanks for watching. Please subscribe if you like this video.